Hello everybody, this video is about the explainable artificial intelligence, the live method with regression in Jupyter notebook. So let's go to Jupyter and we'll start working. So we need to read the data set. For this purpose, we need to import the library on us. So import pandas as id. Then we load the data. Object is my data equal so id.read underscore comma separated value. And the data set is found in this directory. sl dot slash data slash rate. This is the name of the data set. We close the quotes and parentheses. Okay, so already loaded. So exploring the data set. Let's have the head, my data.head, parentheses. So this is what you have in my data. Our dependent variable is ll, then the previous 6 variables here are the features. And we have the transpiration, specific humidity, air temperature, soil temperature, precipitation, and soil moisture abbreviated here. T is time. So let us look at dot describe for the descriptive statistic. So this is what you have. So let's have the output. Input data preparation. Outputs for target is y. So this is the lake level. So y equal my data lake level. So let's have an idea about the head of y. Head the first 5 rows. Then let's see the dimension just to check. One dimensional. Okay, now data or features power x. So power x equal my data. From my data we dropped t, which is time, and our target, which is LL. X is equal to 1. Is how x dot head to have the first 5 rows of x. And this one we have x dot shape to have the dimension 240 observation for 6 variables. So as I remind, always those who are doing research, this is a reminder, is this perform the variance inflation factor analysis and scale the features, and then here x, scale x. Okay, before we go to the next step, which is splitting the data set into training and testing data set. For this purpose, we need to import the train, test, split function. From scikit-learn dot model underscore selection. Import train, test, split. Then split the data. Here have x train, x test, y train, y test equal train test underscore split. I want to split x, y. The test size, I take 0.5%. You can change 20 or 30. It's up to you. Random state, take 30. Shuffle. Shuffle 2. Want it to be shuffle. Extend, test, right hand, right test, okay, the size. Okay, let's verify. Check the dimensions of each of them. Dot shape, x instead of dash. Let's see this one. Data 100 video intervention custom data we have 60 observations. So the next step is to run a regression. Here we need some libraries and functions as well. From scikit-learn dot linear model we need to import reach. We need metrics as well. From scikit-learn dot metrics score, the mean absolute growth, mean square growth as well. We need to run the cross validation. So from scikit-learn dot model selection we need cross val score. We need numpy. And from numpy we need absolute. We need this to transform the negative to positive, and we need to import warnings as well, and from warnings dot filter warnings parenthesis code no. The purpose of this missing T here. Sorry about that. This to ignore all the messages. Okay, so this is what we need to run regression. Okay, so we need to initialize reach. Let's have our model. So reach. In reach, we have the parameters here. Alpha equal 1e to the power -5. Fit intersect 2. Fit intersect equal to 4. Solver equal to LST. Okay, these are the hyperparameters I put here, but before you do that you need to run your own hyperparameter tuning using whatever method you have, but I use grid search to find this. So look at one of my videos. I talk about hyperparameter tuning with regression using grid search. That's how I got this. But yeah, of course you need to run your own hyperparameter tuning before you get here. So we have our reach model. Now we need to fit it to the model. Intersect reach equal model dot fit explain item fit. Now we are going to evaluate the performance of the model. Let's see the intercept. Print the intercept is reach dot intercept underscore. This is the intercept of our model. Let's find the coefficients. The coef. So these are the coefficients. Intercept the coefficients. Okay. Let's have the training model performance. On the training model performance, we first need to predict on the train dataset. So read here equal reach dot predict on X train. So let's print the square. The train R square is to score white train and the corresponding prediction. Read underscore thread tr white train here. Okay, 32%. Let's have to this mask after that. To F. Okay. And print the train in absolute pure is percentage sign to F press the code for the percentage sign and in absolute pure right train and the corresponding prediction. Underscore here 0.30. Let's print the train MSC is mean absolute mean squared. So mean squared error right train and W thread here. So yes. Okay. 0.14. 0.14. Let's have testing model performance. Let's have the prediction and the testing data. Predict X test. Let's print the test R square to decimals. to score. Red, yes. Ok. L'émission, le test underscore is left. Ok. To score. Hyphen LD. Get yes. Ok. Sorry. Oh. Text. White test. No, we are dealing with testing data. White test. Okay. The test MAE is min absolute error white test LD red yes. And the print the test MSP is two decimals min squared error white test LD red yes. Okay, these are the metrics on the testing data set. Let's have our threefold cross validation as well. Verification. And training data set CBTR equal cross val score LG model extrain training data set the input and output the scoring. Take the mean square error. So here we need negative mean squared error and the number of fold 10. CTR. Then we needed the absolute absolute mean and print absolute min, training, see score is absolute, numpy dot new parenthesis underscore tier, and between parentheses we close. Let's have our Christmas as well. Try to have and then percentage sign, and we remove the comma. So it's 0.16. So on the testing data set, testing model, see, yes, now, so as well score, reach, or model, X test, Y test, scoring, equal, negative, mean, squared, error, and the number of folds equal to 10. Yes, that's what we get. Absolute mean score for the training data set is print for the testing, sorry. Absolute mean test validation score is absolute new parenthesis and CV yes close the parenthesis, we close again, close again, 12, 116 point on the train data set, 12 on the testing data set. Good. Now we are going to run our line. Local enter table model agnostic explanation. Explanations. Okay. To install line, we need to install line to the computer. The system before coming to Jupyter by typing Anaconda install Conda Forge line, and I'm gonna print. Or another way is pip install line and command prompt. Okay, after doing that, you need to import line tabular explainer. So here is from line dot line underscore tabular import line tabular explainer. Okay. Now the next step is to initialize the explainer object, an explainer object on the training data set. Training features. So it's the X-train. So here I have explainer, the object equal line tabular explainer parentheses capital L, capital T, capital E. Okay, we have X string dot values we have feature names is the names of the features you have in X-train columns. X-train dot columns is train data set features. Then feature names, after feature names we have class underscore names. Class names equal or y. So bracket code y equals verbos equal to true. Then mode is regression. We are in regression mode. Let me call regression code. Close. So this is our object, explainer object. Initialize on the training data set. Run. Okay, now we are going to explanation on the data set. So on the training data set. So just have explanations on the training data set. Then after we'll be working on the testing data set as well. So there are two possibilities here. The first is explanation of an instance. Then or individual predictions. And then after we have the explanation, the average prediction for the whole training data set. Okay, let's say I equal to, we take 20. This is the index of the instance to be explained. Excuse me. One. And now we have explanation. Let's equal explainer or explaining above dot explain underscore instance. We have explain dot values for this instance I. Then we have the prediction of Jupyter predict. Then the number of features, which is equal to 6. So this is the explanation for the 20th observation. This intercept we have, this prediction we have, the prediction local we have, this is the right prediction we have. If we change to 25 in the data set, this is what we have, and so on, up to 180. So it should be 179, since the index goes from 0. It starts from 0. So let's verify the instance here. Number 20. Let's verify first the prediction. From the model, there is regression model. So each dot red tier of the instance I. Using the same thing, here position right here 53 after that line. Okay, so it's right. It's the explainer for I.quantify, and the prediction from our read model are the same. Okay, good. Let's verify the instance now. Print the instance is this I. Quantify. So here to verify the instance. Now let's have the average prediction. This is true. Average. So average prediction for the whole data set, the whole training data set. So things here, just for instance, explain the prediction for an instance. Here, explain the prediction for all of them. Average prediction for all the training data set. So let's have train, and let's create a list here equal to xtrain dot index dot list. We want the index of all the observation in xtrain to be put in this list, and then we create a dictionary, train dictionary, set to empty now. Then now for n in our list, for n in train index list. Okay, we have the explanation. Explainer dot explain underscore instance. We have xtrain dot log dot xtrain dot log bracket n dot values, and then have our reach dot predict with model, and then number of features we have 6, then number of samples, and the training data set we have 180. Let's see, explain dot show. Yeah, 180. So that's what I put here. So 180 times 4 here. You have it here. Okay, then have an object A to put the explanations as a list, and then we take this list to put in our dictionary for all equal A. So this is what you get. Intercept prediction right, intercept prediction right, intercept prediction right, up from index 0 to index 179. Instead of having just for this index, you have all of them here. Okay. So now let's type our explanation. Okay, let's stop here. So either you have step 1 here, explanation of an instance or initial predictions is here. You have your explanation here. For the one training data set, you have your explanation here with the result as well. So now the plots are going to be on one of these two options. So if you run option 1, you run 1 and you come to the plots. If you run option 2, you run option 2 and you come to the plot. Okay. So okay. Let's speed. Show the explanation in the table. We just type xp dot show underscore in notebook, and then parenthesis show table equal to true. Sorry for typo here. Okay, this is what you have. The predicted value you have here, name, max, and the prediction here, predicted here. You have the features that have positive impact or increase the prediction here, and that negative, sorry, the features that tend to decrease the predictions are here on the side, negative, and those that increase the prediction are on the positive side. And you have below here the feature table. So this is going to be for any of this. As I said before, you run this, you run this. If you are interested in the explanation of an instance or individual prediction, you will skip from here. Make sure this is the one below above, and then you run this. This is for individual. See, look at it very well. That's for instance 25, the index 25. Okay. Now we are interested, if we are interested in the average prediction, we run this code, then we come here, 28154. Okay. The average is 28139 instead of 54 for the I equal to 25. And you see here again the table is changes. So and so on. So let's continue with the output. If you want to visualize the feature importance, using plot figure function, you need to import plt from matplot read.pyplot. So import matplot read, excuse me, pyplot as plt. Then with plt dot style dot context plot here. Cover explanation, dot as underscore pyplot underscore figure. So this is what you get, the feature importance. See here, these are high positive impact in green. See on this side, you see here the something that you see the features here in their respective values, the ranges here, and how they impact. So this is for the average prediction. Okay. If you want to retrieve retrieving the feature and purpose. Sorry, as the list type xp.as_list. The trigger dictionary, explanation dot as map. That's what you have. If you want to retrieve the feature purpose as HTML from IPython dot display. So this here from IPython dot display, import HTML in capital letter, HTML underscore data is an object equal explanation as HTML function here, and then HTML capital letter or data set to HTML underscore data, which is above. Yes, HTML underscore data equal explanation as HTML, importing that. So this is what you have. So it's something like this basically. Okay. So now if you want to print the local and the global predictions, print the local prediction is explanation dot local private, local underscore private, and then the global one is print parenthesis first quote the global prediction is explanation dot predicted value. Good. So we save to file. We have explanation dot save underscore line RG. This is from the training data set, so train dot HTML should be reports. So let's come here, we start with the put. So save to file, line, regression, time, HTML. Terminated string. Okay, here something called the set of double. Okay, so it's already saved. So let's have the same thing in the testing data set. So explanation of individual predictions or instances or an instance or instances. Okay. An individual prediction or instance. Individual prediction instances. We will be changing that. So let's take again I equal 20. For instance, if you want to compare on the training testing data set, so let's have I equal something on the training and testing data sets. So 20 is the index of the instance to be explained. Now let's have our explanation, which one explainer. We initialize on the training data set, so explain underscore instance parentheses, and then we are going to have x test dot value is what bracket I as the instance I, and we have read dot predict is regression model dot predict the number of features, non features equal to 6. So again here we have step 1. Once is just for single prediction. Let's verify again the prediction using the RG underscore predict and the prediction is RG underscore red TS now, and then for I we have the same thing, the right position 281, 22, 8, 281, 22, 35, so on. So get something. Let's do find the prediction. Here, let's print the instance to verify. Instance is SI 25. To run this 20. Yes, instance 20. So sorry, I didn't run it before. So we run this. We run the explainer. That's what we get. 21.134. We verify. 21.13, 45, 45, and now we verify the instance is 20. If you go to 25, run is 21.228. We verify the position is 21.228, and we verify the instance 25. Okay, have this. If you want to show the table, the explanation table, have this dot show in notebook. Underscore in notebook. Show table equal to show underscore table. For the instance, I equal to 25. And so on. You can continue with the plots. Now let's see the option 2. In the wall, explanation for the average prediction for the wall testing data set. So let's have our NX in the training testing data set. Test index, have it as a list, text test, dot index, dot list. Then we have a dictionary. store. This one maybe as of now is empty. And then for in test ind dot list and have explanation equal to explainer dot explain underscore instance parenthesis we have xtest dot n dot values dot predict number of features equal to 6 number of samples equal to 60. Let's verify excess loss shape. Yes, 60. It's 60 here. So the average position for all 60 observations. Good. So let's have an object A equal to the explanation as a list. Then in our test dictionary for the ends we have our A. So this is the average prediction for the whole testing data set. So we have this explanation. We have 60 observations here. Okay, so we have our X. And that explanation part. Okay, now we want to show the explanation table for the whole data set, such as explanation dot show underscore in underscore notebook. Show table equal to true. This is for the whole testing average prediction of the whole testing data set. So we already have our object exp, exp. So on exp we operate to get the output you want to get. So if you want to visualize the feature importance, that's 5 after PLT. You already imported matplotlib as PLT, so with PLT.style the context is a plot here. Explanation as pyplot as underscore pyplot figure underscore figure. Parenthesis. Let's show. When get anything on the training dataset, testing dataset, type here report mat.lib.pyplot as PLT. Okay, continue with retrieving the feature importance as a list. xp.as list. And that's the average prediction again. So retrieving the feature importance as a dictionary. exp.as parentheses. If we want this time have as HTML, from Python dot display. My keyboard not running well. Import HTML. And then HTML underscore data equal explanation dot as underscore HTML. Then HTML parenthesis data equal to our HTML underscore data. So this is what you get. The same as this one. We're going to save this HTML file. So here again you do the same thing on the testing dataset to compare with what you got on the training dataset, how the explanations are based on line and the training and testing data set. So retrieving local and global predictions. And the local prediction is x dot web. And now the global prediction is explanation dot predicted value. Predicted underscore value. Here we save the feature importance. It's an HTML file. Type explanation dot save underscore to underscore file. We delete a name. We put code first. So put line with regression underscore test this time dot html. Good. And then run it. So in this video we went through this regression first. We got the model performance on the training and testing data set here. Then we got to line, and the line on the training and testing data set. We have our explanation on individual predictions. This on the training data set. This is how we got for individual predictions. And then we went to having the average prediction here, the whole training data set. And on each of them we get our outputs, figures. This is the explanation table. Then this is the feature importance figure, this and the dictionary of the feature importance with the HTML file, local and global prediction as we save. When to the testing we do the same, having the explanation for the individual predictions with the instances here, and in the here's for the prediction for the average prediction, the explanation for the average prediction for the whole testing data set, and then we have the respective figures and the output tables, and we save them. We save the HTML explanation table. The tables here, the explanation tables are saved in the folder where you download your Jupyter in Anaconda. So mine is here. PC, I go to local C, I go to users, I go to administrator. In administrator, this is here I have my Anaconda here, see everything that is here. Anaconda Python Jupyter is installed here in this folder. So this is where I have all my notebook files stored automatically here. So this is where we'll find our tables here. So we have train, line, LD train HTML file, this here, line, LD underscore train HTML. That's how we have it here. This is for test, line, LD test HTML. Here for the training data set. We'll go back here, open the second, this for test testing data set, client rd underscore test. So this is this second. What we have here, and we save it. So once you have them as HTML tables, you can manipulate them as you want. You can save them here, take a screenshot and save them as figures, what type of image you want, JPEG, PNG or TIFF, or there are other ways of outputting this. So we are at the end of this video. I hope you get something from it. Today you are research, and those are doing research or assignments. So thank you for watching.